Welcome to the Deep Dive. Today, we're jumping into some really core ideas in modern operations and supply chain management.
That's right. We're looking at lean, agile, and resilience. Big topics.
Definitely. And our mission really is to get a quick handle on how these philosophies differ, how companies try to balance, being super efficient versus being quick and flexible.
It's that classic tension, isn't it? Cost versus speed, especially when things are so uncertain out there.
And a lot of that balancing act, it seems to boil down to inventory, making sure you have just enough stock to economically meet demand commitments, something like that.
Pretty much. It's this blend of science and maybe art in managing your stock levels. We'll touch on things like capacity, how stuff flows, planning versus pulling, and crucially, risk.
Okay, so where do we start? Maybe with the older ways of managing flow.
Yeah, good starting point. Traditionally, you had what we call push systems. Think statistical stock control. You order stuff based on like a set level, the reorder level, ROL, or on a fixed schedule, the reorder cycle, ROC.
So you just keep ordering the same amount or ordering every month, regardless of what's actually happening on the factory floor right now.
Pretty much. It pushes material into the system based on forecasts, not necessarily immediate need. Simple, maybe, but often disconnected from reality.
Right. Which I guess leads us directly to Eli Goldratt and his book, The Goal. That really shook things up, didn't it? Theory of Constraints, TOC.
Oh, absolutely legendary. TOC. And the software ideas behind it, like optimized production technology or OPT, it fundamentally shifts your focus.
Yeah.
You stop trying to make every single machine run flat out all the time.
Because that just builds up inventory everywhere except where it matters.
Exactly. It creates local efficiencies that actually clog up the whole system. Instead, TOC says, forget all that. Focus only on the bottlenecks.
The bottlenecks.
Yeah.
So the slowest parts of the process.
Precisely. The one or two steps that dictate the entire system's output. Making anything else faster doesn't help the company ship more product. It just creates more piles of waiting parts.
That sounds counterintuitive, but powerful. Ignore most things. Focus only on the weak link.
It is. It gives managers permission to, well, not optimize everything. Identify that constraint, the machine where work always piles up, and make sure it never, ever stops.
So you buffer it. Keep feeding it work.
You do. You put a time buffer of inventory right before it, maybe assign your best people there, schedule everything else around its needs. That bottleneck becomes king. Its rhythm is the company's rhythm.
Okay, that covers the flow aspect. But even before you get into complex systems, there's a basic economic calculation for ordering parts, right? The EOQ.
Ah, yes, the economic order quantity. Classic inventory theory. It's pure math, really. You're balancing two costs against each other.
The cost of actually placing an order, admin, shipping, all that.
Against the cost of holding the stock, warehousing, insurance, the risk it goes obsolete. EOQ tries to find that sweet spot, the order size, where your total cost is minimized. For that one specific item, anyway.
Right, for one item. But what happens when you have, like, thousands of components going into one finished product? EOQ can't handle that complexity.
No, it really can't. That's where you need a planning system that sees the bigger picture. And that's where MRP, materials requirements planning, really comes into its own.
The brain behind most stock control software packages.
Pretty much, yeah. MRP is designed for what we call dependent demand. The demand for, say, a bicycle wheel depends directly on how many bicycles you plan to build. You don't forecast wheel demand independently.
Okay, and it works by looking ahead and planning backwards.
You got it. It takes the master plan, what finished goods you need and when, and it explodes that requirement down through all the levels. Subassemblies, components, raw materials.
Using the bill of materials, right?
Yeah.
The recipe for the product.
Exactly. It figures out everything you need, checks your current inventory, factors in how long it takes to get each part the lead time, and then tells you precisely when you need to order or start making each component to meet the final deadline.
Let's try that table example. 200 tables needed in week 12.
Okay, so master production schedule says 200 tables, week 12. Each table needs, let's say, 4 legs. Simple math. Gross requirement is 800 legs for week 12.
Step 1, explode. Then check inventory. Say we have 350 legs already in stock.
Right. Inventory status check. So 800 needed minus 350 on hand. Net requirement is 450 legs.
But you can't just snap your fingers. Lead time.
Let's say it takes 3 weeks to get legs delivered. So if you need them by week 12, MRP calculates backwards and tells you the purchase order needs to go out or the production order needs to start back in week 9.
Explode, compare, offset by lead time. Got it. That's the core logic.
That's the power of MRP for managing complexity. And it didn't stop there, of course.
It evolved. MRPII, Manufacturing Resource Planning.
Yeah, MRPII tried to bring in more reality. It started considering capacity. Do we actually have the machine time or labor available? It added feedback loops, making it closed-loop MRP.
And from there,
Yeah.
the big one, ERP, Enterprise Resource Planning.
The grand vision. ERP attempts to connect everything, not just materials and production, but finance, sales, HR, engineering. A single integrated system for the entire business. One source of truth.
Sounds amazing on paper, but the sources mentioned a pretty big but. Implementation is very complex and difficult in practice. Why is that? It seems so logical.
It's rarely the technology itself that's the killer. It's the human element and the data. ERP forces standardization. You have to make different departments agree on common processes, common data definitions, things they might have done their own way for decades.
Political battles, basically.
Often, yes. And data. Oh, the data cleansing.
Yeah.
Years, sometimes decades of inaccurate inventory records, messy customer files. You have to fix all that before the system can work reliably. It's a massive undertaking. Scope creep is rampant. Many projects fail or go way over budget.
So if it's such a beast to implement, why do companies keep chasing this ERP dream?
Because the prize is huge. It all ties back to working capital. Inventory's cash, tied up. If you can manage your materials and resources perfectly, plan accurately, reduce stock safely, you free up enormous amounts of cash. That's the lifeblood of the business. ERP, done right, is the ultimate tool for optimizing that.
Okay, so that's the world of planning, forecasting, and pushing materials through the system.
But then there was a completely different approach that came along, mainly from Japan.
A total paradigm shift, yes.
Yeah.
This is where we get into the pull systems, just-in-time, or JIT, and the broader philosophy of lean management.
And the core idea isn't just planning better, it's something else.
It's fundamentally different. The goal isn't optimization, finding the best solution based on current constraints. The goal is Kaizen, continuous improvement, the belief that every process has waste and can always be made better.
And JIT does this by actively fighting against the things that MRP accepts, like ordering costs, lead times. Precisely. Traditional thinking, like with EOQ, accepts that ordering costs money, so you order large batches. JIT says, no, that ordering cost is waste, let's attack it. Let's reduce setup time, streamline purchasing. Same for lead times. Holding costs attack the root causes that force you to hold inventory.
The aim is to run with almost no stock.
Ideally, yes. Low stock forces synchronization and exposes problems. Which brings us to that brilliant analogy, the JIT pond.
Ah, yes. Explain that. How does lowering inventory drive improvement?
Okay, imagine your production system is like a ship sailing on a pond. The water level is your inventory.
High water level, smooth sailing.
Exactly. When inventory is high, the water covers up all the nasty rocks and obstacles hidden underneath. Yeah. These rocks are your problems. Machine breakdowns, unreliable suppliers, defective parts, long changeover times, level 1, level 2 problems, you know.
So high inventory hides the problems. You don't even know they're there sometimes.
Right. Lean philosophy says, let's systematically lower the water level, deliberately reduce the inventory. What happens?
Crash. You hit a rock.
Exactly. The problem is exposed. And because you have very little buffer stock, you have to fix that problem immediately. You can't just work around it. So you fix the unreliable supplier or you slash the setup time.
And once that rock is dealt with,
you lower the water level again, expose the next rock, fix it, lower again. It's this relentless cycle of forced problem solving, continuous improvement driven by making problems visible.
Okay, that makes sense conceptually.
Yeah.
But how do you actually control the flow day to day without a big plan like MRP?
Yeah.
How do you implement that pull, not push?
That's where Kanban comes in. It's the control mechanism for JIT. Kanban just means signal or card in Japanese.
Like literal cards.
Often, yes, or empty containers, or even electronic signals now. The idea is simple. A downstream process, say final assembly, uses a part from a container. When that container is empty, it acts as a signal a Kanban sent back to the upstream process that made the part.
Telling them to make exactly one more container's worth.
Exactly. Make one, take one. It pulls material through the system based on actual consumption, right from the final customer demand backwards. No complex forecasting needed for the shop floor execution, just respond to the Kanban signal.
Okay, so we have these two big philosophies. MRPRP focused on planning and efficiency via forecasting, and JILEAN focused on continuous improvement and efficiency via eliminating waste and inventory.
Yeah.
But how do you choose? Can one company use both?
Now we get into strategy. And that's where Fisher's work from the late 90s was so important. The Fisher Matrix basically said, you absolutely cannot use the same supply chain approach for every product. It depends on the nature of the product itself.
Right. He split products into two types. First, the functional products.
Yes. Think staple foods, basic t-shirts, standard screws. These have predictable demand, long life cycles, low variety, stable prices, thin margins.
And for those, the strategy should be
Lean supply chain management. Pure efficiency. Your goal is lowest possible cost. Minimize inventory, eliminate any waste, streamline everything. Standard stuff. Predictable demand, perfect for lean.
okay. And the other type, innovative products.
These are the opposite. Think fast fashion, new smartphones, seasonal items. Demand is unpredictable, life cycles are short, lots of variety, high margins initially, but big markdowns if you're left with stock.
So for these unpredictable products, lean would be disastrous.
Absolutely. You'd miss sales or be stuck with obsolete inventory. For innovative products, you need an agile supply chain management approach.
And the goal here isn't cost, it's
Responsiveness, speed, flexibility, getting the product to market fast, being able to ramp production up or down quickly based on volatile demand. Your KPIs are things like time to market and ability to handle uncertainty, not just cost per unit.
But, I mean, most companies sell a mix of products, right? Or they want lean costs but agile speed. How do they manage that?
That's the million-dollar question, and it leads to hybrid strategies. The key enablers here are things like mass customization and, crucially, postponement.
Postponement, delaying the final configuration.
Exactly. You design products modularly, you make or buy standardized components and subassemblies using efficient lean methods, maybe based on a forecast. But you delay the final differentiating steps, color, packaging, software configuration, until you have an actual customer order.
So you push the generic stuff efficiently, then pull the specific customization quickly.
Precisely. And this leads to the idea of the decoupling point. It's a strategically chosen point in the supply chain, usually an inventory buffer,
Okay, what happens at this point?
upstream of the decoupling point, making the generic modules you operate using lean principles. You focus on efficiency, maybe driven by forecast, economies of scale. Downstream of the point, doing the final customization and delivery, you switch to Agile. You're driven purely by actual customer orders, focusing on speed and responsiveness.
So the decoupling point is where the push strategy meets the pull strategy.
That's a great way to put it. It allows you to get the best of both worlds, matching the supply chain mechanism to the predictability of demand at different stages.
That sounds like a really smart way to balance things, but it still feels like we're missing one piece, especially given, well, the last few years, resilience.
Yes. The third pillar, and maybe the most critical one right now. You can be lean, you can be agile, but if your supply chain shatters at the first sign of trouble, none of it matters. Uncertainty is the name of the game now.
Demand volatility, resource shortages, price spikes. It seems constant.
It really does. And this is where the idea of resilient operations becomes not just a good idea, but an absolute imperative. We saw with, Brexit, the pandemic, the war in Ukraine. These massive disruptions just broke supply chains that were maybe too lean, too optimized for cost without considering risk.
So resilience is about planning for those big unexpected shocks, the high-impact, low-probability events.
Exactly. It's about systematically identifying potential disruption risks, supplier failure, geopolitical events, natural disasters, and building in capabilities to withstand or recover from them quickly. Things like having backup suppliers, holding strategic safety stock, designing for flexibility. It echoes risk management frameworks like Kaplan and Mike's described.
And when these disruptions hit, they often trigger that nasty feedback loop, the bullwhip effect.
Oh, the bullwhip effect, the bane of supply chain planners.
Yeah.
It's how small changes in customer demand at the very end of the chain get amplified like crazy as they move upstream.
So, like, a small uptick in store sales causes the retailer to order a bit more from the wholesaler.
Who sees a bigger jump and orders even more from the distributor, who sees a huge spike and tells the factory to ramp up massively. Each step adds its own buffer and safety margin, exaggerating the original signal.
And then demand stabilizes, but the factory has produced a mountain of product based on that amplified, distorted signal.
Precisely. It leads to wild swings in inventory and orders all the way up the chain. Massive inefficiency, huge costs. Disruption and uncertainty make the bullwhip crack even louder.
So dealing with this means companies now have to actively invest in risk strategies, not just react.
Yes, Mature organizations are now dedicating serious resources to risk management. They're using simulation modeling, scenario planning. What happens if our main port closes? What if this key supplier goes bankrupt? Building contingency plans, ensuring compliance. It's about proactively building shock absorbers into the system.
Wow. Okay, so wrapping this all up, we've gone from managing flow with TOC to planned efficiency with MRP-ERP, continuous improvement with Lean GIT, responsiveness with Agile, and now buffering against shocks with resilience. That's a lot for a manager to juggle.
It really is. The modern supply chain leader has to be, well, ambidextrous. You need to understand all these philosophies. Lean forces you to attack internal problems by cutting buffers. Resilience forces you to manage external volatility, sometimes by adding buffers or redundancy. They often conflict.
So it's a constant balancing act.
Yeah.
One day you're focused on shaving pennies off costs, the next you're worried about a supplier halfway around the world shutting down.
Absolutely. You're constantly asking, are we optimizing for costs today or ensuring we can respond tomorrow? Which hat do I need to wear right now?
Which leads to a final thought for you, the listener. In your world, which pressure is greater right now? Cost reduction or resilience? Getting that balance wrong, as we heard, is how a small ripple becomes that bullwhip tsunami. Definitely something to think about.
Indeed. And understanding that bullwhip effect is key to navigating the current volatility. Until next time.